Hello and welcome. Today we are doing chapter 4 of our book, The Art of Reasoning, and that chapter is argument analysis. So, to recap from the previous chapter, here's a couple of things that we have going on. In chapter 1, we sort of looked at the idea of pointing, right? Identifying things that we are trying to talk about, right? So you got to be able to select a thing. So the act of kind of running down that tree and finding just the one thing that you want is kind of like a small child pointing at an object trying to get it. In chapter 2, we moved past pointing and we started developing language, right? So now you have a word for a whole definition. So at this point, the child is able to not just point, let's say, at a cat or a dog, it's able to say cat or dog. And there's a bunch of features that go into these ideas. So if I say laptop, you don't think of your smartphone, even though it is a computer and it can fit in your lap, right? There are certain criteria that make a thing a thing. So getting the definitions right is really important because it allows us to transfer a whole bunch of sort of pointed meanings in a single bundle to the other person. And in chapter 3, we looked at essentially forming sentences. So at that point we started actually communicating, right? So that's the idea of meaning and sentences. So you can see how this entire project here is building on itself. Now at this point we are able to communicate with other people. We can make statements in a way that can make those statements true or false. Right. So in chapter 4, which is what we're doing today, is we are going to see what happens when we take a bunch of these sentences and we stack them on top of each other, right? And that's called arguments. And as the book points out, we're not talking about arguments as in getting into a heated argument with somebody and yelling. We're talking about arguments in terms of being able to communicate multiple ideas stacked on top of each other. All right, so the first point I think that we should make, just to sort of make sure we're all on the same page, when we're talking about arguments, what we are going to do is we are going to have stacks of propositions. So that means that you need to have propositions, which are defined over here in our chapter 3, in order to build up arguments. Seems pretty straightforward, I would like to think, but let's sort of show how all that works. So you have your stack of propositions, and you have a number of propositions that you already believe, and you lead with those when you have an argument, and those are called premises. And these are supposed to be things you believe, or perhaps even know, are true. Right? And then you're supposed to take these premises, so these different propositions, and you're supposed to be able to bring them together in a way that gives you a conclusion that is a little bit more than just the premises themselves. Let's call that the outcome of our premises. So a simple example, one that gets used quite often in philosophy classes, looks something like this. Our first premise is all men are mortal. Our second premise is that Socrates is a man, and that gives us our conclusion down here. Socrates is mortal. Now notice that each of our premises is a proposition, right? So here is your subject, and here is your predicate, subject, predicate, right? And then we end up with our conclusion, which again is a subject, predicate kind of thing. Easy enough. Now, how did we end up with this conclusion? Well, you can think of it this way. Let's see, is that going to work? Yep. You can imagine that these sentences are sort of built like this. Here's our subject. We'll call this A, something about people. And then mortality is our point B. This here is C. It's a new term, right? It's not men or mortal, it's Socrates. Then here we have the term is a man. And you see that that matches with all men. Okay, so just like in math, when you find on different lines same terms, what you can do is you can just sort of cross them out. And the remainder is that Socrates is mortal, which is what we have here. So this is C, B. That's sort of the outcome. So that's the simple way of how this works. Alright, so on page 70 of the book you have some indicator words to help you identify premises and conclusions, and then there is a warning that there is a difference between descriptive statements and arguments, right? So the descriptive statements are just sort of explanatory. It's not an argument. It's just sort of an explanation, and there is frankly a difference. So you got to keep an eye out on that so you don't misread what's going on. All right, diagramming arguments we're going to skip. You guys can play with that. Induction and deduction. This is a really, really, really important point because you will actually see this come up quite a lot in the way that people talk. So deductive arguments are all about just this setup right here, right? So you get your conclusion straight from your premises. Okay. Now this is the solid version of making an argument, and you can actually think of this as math. So imagine that we have two sets of premises, and then we have our conclusion, right? And what we're doing here is our premise 1 is, let's say, 2 plus 2, so you need a solution to that. And then our premise 2 is square root of 9, okay? And then you add up those results, and the outcome here is what you get, right? In fact, actually, square root of 9 might not be the best example. Let's say 3 squared works better. Alright, so 2 and 2 is 4, rather obviously, right? And 3 squared is 9. Okay, 9 plus 4 is 13. Notice that there is no other possible answer here, right? So this is the only possible answer. And that's what the deductive argument does for you, right? It gives you the only possible conclusion. And where you can get it, you should definitely be using this form of argument. Of course, the problem is we can't always sort of set it up that way. So that's where the other kind of argument comes in, and that one's called inductive. And in the case of inductive argument, you are getting your conclusion by going beyond the premises. So this one's kind of tricky. I mean, in fact, you can't even represent it with math the way that we just did, the deductive argument. But in essence, what you're trying to do is you're trying to take limited information and then somehow build a larger system around it. And we do this actually all the time, right? So for example, let's say I drink water when I am thirsty. Right, that's our premise one. Second is Bob drank water. So our conclusion is that Bob was thirsty. Right? Now you're sort of doing the same thing here, right? Here's your subject. Here is the predicate. Here's the subject, and here's the predicate. So you're going to get rid of the drink water and drank water, and now you have Bob being thirsty. The problem, as you may notice rather quickly, is that there is more than one reason why somebody might drink water. So you might be drinking water because you're just trying to get in your 8 glasses of water a day or something, right? So you're not actually thirsty, you just think that it's health related. Or maybe somebody told a bad joke and you're trying to cover up a smile or something, right? It doesn't matter what it is. The point is that you can't actually guarantee that Bob was thirsty, right? You have to sort of guess your way to it. So this is not the only possible answer. This is possibly an answer. So our book walks us through a number of options, right? Deductive arguments have sort of 2 parts. There's a question of validity, and that validity is, did you get your conclusion from your premises? Now, if you did, then your argument is valid. But there's a problem. What happens if one of your premises was wrong? Well, that's why we have a secondary option. A deductive argument is sound if it is valid, and remember from last chapter, that means that both of the statements have to be true. So it has to be valid, and premises must be true. And that is the most sort of certain that you can possibly be regarding things. Now, in the inductive argument, you can't quite have the same setup, because you can't have a valid inductive argument. Why? Because the conclusion never follows from the premises. The conclusion is always bigger than what the premises have. So we worry not about validity here, we worry about strength. And that one's a lot harder to sort of quantify, right? You're asking sort of like, how likely is it? And this whole idea of how likely now starts depending on things like statistics and your percentage chance and all the rest of that. And the book goes into that at a later time. You sort of need to be aware. Now, the problem for inductive arguments is still the same as it is for deductive arguments. What happens if your premises are not true? Well, no matter how strong your argument is, if your premises are bad, then you're going to end up with the wrong conclusion. So we also have that second part, and that they call right, so for cogent, right? Yeah, cogent. An inductive argument can be cogent if it is strong and it has true premises. Alright, so anything that we can't sort of directly observe and work out in this deductive way, you'd be surprised how few things we have there, ends up just sort of having to rely on it's an inductive argument. So for example, in physics, the speed of light is supposed to be the fastest speed at which anything can happen, right? Because no signal is believed to be able to travel faster than the speed of light. But, and here's the trick, we don't know whether that's actually true, right? We have a really good inductive argument for that, or right up until you get into things like, if you want to give yourself a headache, check out quantum entanglement. And these are particles that seem to react faster than the speed of light. So, whoops. So, this becomes sort of like the holy grail of science, right? We're working off of best understanding of what we're dealing with. On the other hand, math isn't subject to the same problem, right? Math just sort of does its thing. Right, so that gives us induction and deduction. Implicit premises, I think it bears noting for a second. In fact, here we can take a look at the Socrates thing. Right, so our first premise says that all men are mortal, and our second one says that Socrates is a man. Now, we assume that this idea of man and man are linked in a way that, so we can say, hidden assumption here is something like the idea of men, or humans in general, has not changed since Socrates. Right, because if it did, all of a sudden you couldn't actually make this argument. So you might be thinking, well, that's weird, why would you expect these things to change? Well, maybe Socrates isn't the greatest example, but if we were talking about something like laws or different relations, laws, for example, or the application of laws is rather interesting. So if we talk about slavery, for example, it really matters when are we talking about it, because slavery was legal. So if you looked at a law and you didn't know when it was passed, but what you did know is that it set whatever it limited the punishment for escaped slaves that would suddenly seem rather weird, wouldn't it? Unless, of course, you knew that that law, for example, comes before the Civil War and the end of slavery and all the rest of that. So some things do very much change, and so it's really important, especially in inductive arguments, right, to make sure that you can that your terms actually mean what you think they mean. Same thing for example, being tried, right? You are a minor at some point, but then you become an adult at a later time. Now, the way that we can and can't charge you as a minor is different from the way that we can and can't charge you as an adult. So you can't assume that the thing that was true before is true now. We used to be at war with Great Britain, and now we're allies, right? So all of these things change, and you have to sort of figure out like what is being assumed here by the speaker. This is especially important when you read things that might be old, or so key features, things like age, the rest of the sort of context. So if you read somebody like Mark Twain, he uses a particular vocabulary, right, because he's writing in the 1800s, when he's referring to African Americans. Now, it might be easy to assume that what you're looking at is racist, but that would be incorrect. And the reason why it would be incorrect is because the implied assumptions are now different, right? The reason why he uses some of the language that he does is because those were the only terms available, right? You would run into the same problem if you tried looking up MLK's I Have a Dream speech. Now, if you didn't know who the speaker was or when they were speaking, right, age again comes into play, you might find that entire thing offensive, right? For the sake of argument, if I were to use that language just in my ordinary speech, it would in fact come off as offensive, and perhaps it should, right? The trick is, though, you need to know who is speaking and when in order to be able to differentiate what are the implied assumptions in what it is that you're reading. Alright, we have some distilling the arguments. We can sort of skip that. Alright, I think that will actually sort of do it for chapter 4. One moment. So this is our setup. We started off with the idea of pointing, moved on to definitions and bundles of ideas. Then we started putting those things together into sentences and propositions that will allow us to communicate meaning so that we can have things that are true or false. And then when we stack those things together, we end up with arguments. And arguments are built up of premises and conclusions, and they can be deductive or inductive, and that changes sort of what we're expecting out of them and how heavily we can rely on them and things like that. Now for chapter 5, we are going to sort of turn this around, and we are going to sort of ask a question, how can arguments go terribly wrong? And the reason we want to know that is before we really get into the whole building up arguments, we need to understand what it is that makes arguments work well and what it is that breaks them, and the most common ways in which we sort of make mistakes when we're both trying to put together our arguments and when we're trying to understand somebody else's arguments. So the entirety of chapter 5 is going to be on this thing called fallacies, and those are the sort of basic mistakes in reason that lead you astray. Alright, that's it. If you got any questions or comments, please let me know, and I'll see you all next time. Take care.